Right, here we have the same counter that we had in the first episode, and we're going to be using what we learned to listen to changes in state of the counter. So if you missed that episode, please go back and watch it to bring you up to speed. Now at the moment, I'm just outputting the value of counter, and we know that that is actually the wrapped value of the state property wrapper. So when we click the button, it works exactly as expected. Now say instead of the counter itself, we actually wanted to output some state based on the value of the counter. So we wanted to update some other state whenever the value of counter changes. How might we do that? The first thing we would do is set up some state to represent that. So I'm going to put it underneath our counter, and I'm going to call it counter text. And this is going to be a string of 0. It starts with the same string representation of the counter, and that is all it's going to be because we want to keep this thing nice and simple. Instead of counter, we're going to output counter text. And then being good developers, we're going to set up a function that manages change in that state. I'm going to put it under the body, private func update counter text. It's going to take a value that is an int. It's not going to return anything because it's going to be setting the value of counter text inside. Counter text is the string representation of the value we get passed in. And at this point, we want to be observing changes in counter. So we add an observer to counter. Whenever it's set, we say update counter text with the value of counter. Seems reasonable. Let's resume and see the fruits of our labor. We go to our button, and absolutely nothing happens. Based on what we learned in the first episode, this shouldn't be too surprising to you. Because remember, we are actually able to simulate this without annotations, and we can make the counter a constant when doing that. And this is because if we look again at the definition of state, we can see that the setter on the wrapped value is in fact non-mutating. And if something is non-mutating, then we are unable to observe changes in that. There are actually two ways that we can approach this. The first way works on iOS 13 and 14, and the second way we're going to look at only works in the latter. So let's look at the more general solution first. One thing we've learned is that on line 18, we're accessing the projected value of state, which is a binding. In other words, all we need to do on line 18 is supply a binding to the button updating counter. If we take a look at the definition of binding, we can see that there's an initializer that takes two closures. So if we construct our own one of these by providing our own get and set closures, then we can monitor changes in that and manage the state of counter ourselves. Let's get rid of this observer. And remember, this is not going to be a binding that is associated with the state that is managing our counter. This is our own binding. So we're going to have to drive the state of our counter by using it as a delegate to speak to our counter on line 7. You'll see what that looks like in just a second. So I'm going to say let counter binding is going to be a new binding where the getter is actually our counter. So now reading from our new binding will return our counter, and the setter is where we can set our counter to whatever value the binding is set to. Counter equals $0. Now let's look what happens if I use this new counter binding instead of the projected value from state. So I'm going to replace this with counter binding. I'm going to output counter for now. And if I resume, what we're going to see is everything working as normal. So this delegate binding that we've created is wrapping access to our counter. So now we're in a position where we've got access to the new value as it's changing, and we can just update our counter text. So we'll put counter text back in here and say update counter text with the new value. And now it's working as we would hope. So we're now listening to changes that happen in the button updating counter and responding to them. Excellent. Now this is a bit messy, cluttering up your body like this, and it's quite specific to our needs. What if we wanted something a little more general? Well, we can create an extension on binding for this, which will be generic for all types and can be used with impunity. So let's take what we've got there and put it in an extension. I'm going to say extension on binding, and this is going to be called onChange. It takes a handler, which is going to be escaping. And the signature on the handler that we want to use is going to be typed to the binding. Now, in the definition of binding, if we pull that up again, we can see that the type of the binding is actually value. It's not a great name, I think. Probably should have been called T, perhaps. But that's the thing that defines the type that the binding is wrapping. So our closure is going to take in something of type value, and it's going to return void. Value returns void, and this whole thing returns a binding typed to value. And now we grab this lot, move it down to our onChange function, and now we've got some changes to make. Firstly, we're just going to return it. Secondly, the counter is representing the wrapped value in this case. Remember, the wrapped value is the thing that every property wrapper has. In the getter, we're actually going to return that, and we're going to be setting that in the setter. We can say wrapped value. Obviously, update counter text doesn't exist within binding, so we're going to call our handler. And our handler is going to take the same value type as the wrapped value, which means we can just call the handler by passing in the new value that's getting set. So I can say handler and pass in the same value like that. And the last thing we need to do to make this work is on line 14. Originally, we were using the projected value of counter, which returns a binding. And now we have an extension on binding, we can just call onChange on that. So I can go up here and say $counter onChange. And because the handler in this case is requiring an int, since that is the type of the binding, we can just pass the function name because it has the correct signature. Update counter text. All right, so let's resume and see if it's worked. Well, would you believe it? We've got a nice, flexible way of listening to on-change events for state. If you remember, I mentioned an iOS 14 specific feature. Well, it turns out they've actually made things even easier for us. We don't need to do any of this anymore because they've provided an Unchanged Modifier that we can use for any value changes that we want to observe. Instead of onChange here, I can put onChange on anything really. So onChange, we're listening to value changes in counter. And the thing we want to perform is just going to be update counter text again, because the type of counter dictates that the type of the handler is going to want to take an int as an argument. And it also returns void. Update counter text. All right, no need to resume. I've only been modifying the body, and I can click and everybody is happy. So there are two ways of listening to changes in state. You can decide which one is better for you. Or if you have other ways you've found of doing it, let me know in the comments. In the next episode, we're going to be looking at how we can use what we've learned so far to create an edit screen and use state to manage the changes in those entities. And you're going to find it really useful. So join me for that. It's going to be brilliant. If you learned something, like the video, and if you want to see more of this kind of thing, consider subscribing. If you have any questions, comments, or suggestions, please leave them below. But in the meantime, thanks for joining me. See you next time.